Hello, Swagatam students to Vedantu Malayalam channel where we are preparing for KEAM 2023 exam. So we have brought a crash course for all of you for physics, chemistry and maths preparation in a very crisp and fast manner so that your entire syllabus is being revised for all of you. Along with the revision of the chapter, we will also do previous year question paper questions to give you an idea what type of questions will be asked in your paper. And at the end of every chapter, I'll provide you with the mind map and formula cheat sheet of the entire chapter, which will be super helpful at the revision time before your exam. Okay, so if you are preparing for KEAM, then Vedantu Malayalam is the best channel for you because in 1 month we are going to make you 100% well prepared for the KEAM exam. So guys, today we are picking up matrices chapter because this chapter every year is asked with a lot of questions. You will see matrices and determinants having 10 to 12 questions, especially from matrices itself. You will have 6 to 7 questions which will give you 24 to 28 marks, and every year it is guaranteed that matrices and determinants chapter is going to come in your exam. Okay, so that's why I'm picking up the highest weightage chapters first of all so that you are well prepared with them, and later on we'll obviously complete all the chapters as well. So if you are new on this channel, subscribe right now, right away for physics, chemistry, maths regular lecture. I am Sana Khan. I will be taking your maths class. We also have Shibila ma'am who will take your chemistry and Lerin ma'am for physics. Okay, so do subscribe to the channel and share this video with your friends also. Now, without wasting any time, let's get started with revision of each and every topic present in matrices. Okay, so starting with, what is a matrix? Matrix is an array representation of numbers or functions. So basically we use square brackets to represent the elements. The elements are basically the entries and they are nothing but numbers or functions. Okay, written in the square bracket form. Need not to be a square, it can be a rectangle box also, but the elements are written like this. Okay, now every matrix will have an order. What is the order of a matrix? So if you write the matrix name with a capital letter, you should always denote the number of rows and the number of columns it has. Now what are rows and column? Suppose you have written a matrix like this, A, B, C, D, E, F. So this is called as row number 1. This is called as row number 2. This is called as column 1, column 2, and this is column 3. So the horizontal lines will be rows and the vertical lines will be columns. Okay, so we always represent the order of the matrix as row by column. How do we pronounce it? Row by column. So if a matrix is of order 2 cross 3, it means it has 2 rows and it has 3 columns. Clear to everybody? Now, if you want to find out number of elements, please note down the formula for number of elements in a matrix. It is asked in questions. Okay, number of elements in a matrix is always equal to number of rows into number of columns. Okay, so what type of question can be asked? Suppose they will give you a matrix like this. They'll ask, what is the order of matrix? So order of the matrix will be number of rows 1, 2, 3. So there are 3 rows and how many column? 1, 2, 3, 4. 4 column. So this is the order of the matrix. Now similarly, how many number of elements? Number of elements. Number of elements are number of rows into number of columns. 4 3s are 12. So basically 12 elements or 12 numbers are there in the matrix. You can count and check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 elements. Fine. Okay. So this is order of a matrix. Next, there are some typical types of matrix. You should know their names because in the exam they may ask you that what type of matrix is this, or they can directly tell you that it is a column matrix, do so and so. So if you don't know what is column matrix, how will you solve the question, right? So what is a column matrix? A matrix is said to be a column matrix if it has only one column. For example, if the matrix is written like this, A, B, C, it has only one column. So it is a column matrix. Similarly, what is a row matrix? If a matrix has only one row, then it is a row matrix. Columns can be any. Columns can be 1, 2, 3, 4, but row should be only one. Row matrix. Then a square matrix. What is a square matrix? If the number of rows are equal to the number of columns, then we call it as a square matrix. For example, a 2 cross 2 matrix or a 3 cross 3 matrix or a 4 by 4 matrix. They are what? Square matrix. Okay. Next is diagonal matrix. Diagonal matrix is a matrix that has only elements, numbers or functions in the diagonals only. So for example, here you have A, B, C. Apart from this, every other element should be 0. Every other element should be 0. Okay, and so that means only in the diagonal you will have numbers. Apart from that, everything will be 0. Now this is a diagonal matrix. Condition is it should be a square matrix, only then it can become a diagonal matrix. Okay, now diagonal matrix can become scalar matrix. How? So if your diagonal matrix has basically same numbers in the diagonal, A, all the elements, all the numbers are same in the diagonals, then it is called as a scalar matrix. Okay, clear? And lastly, we have identity matrix. Again, a diagonal matrix is called as an identity matrix if all the numbers in the diagonals are 1 only, 1, 1, 1. So it will be called as a identity matrix, also denoted as I. So in your question, if I is written, you should remember they are talking about identity matrix. Okay, this is a 3 cross 3 identity matrix. Similarly, a 2 cross 2 identity matrix will be 1, 0, 0, 1. Only the diagonals having 1. Okay. Next, zero matrix. Now zero matrix is pretty simple. If all the elements are only 0, 0, 0, 0, 0, 0, 0, then it is a zero matrix or a null matrix. Alright. Now, this is one of the most important topic asked several times in the previous year questions. Equality of matrices. Super easy topic, super scoring topic. Okay. What is equality of a matrix? If there are two matrices having same order, what is important? Same number of rows, same number of columns. Example, if I have a matrix where A, B, C, D, E, F, there are 2 rows, 3 columns. And I have a B matrix which has 4, 5, 6, 1, 2, 3. Again, 2 rows, 3 columns. Then if A is equal to B, then first element will be equal to first element. So A will be equal to 4. Second element will be equal to second element. B will be equal to 5. C will be equal to 6. D will be 1. E will be 2. F will be 3. So this is equality of matrices. What type of question is asked? This type of question is asked every year. Every year they ask this type of question. So please practice it along with me. First element will be equal to first element. Why? Because the matrices are equal. So 2A plus B is equal to 4. Clear? Similarly, second element will be equal to second element. So A minus 2B is equal to minus 3. Okay. Now using these two equations, can I get the value of A and B? Yes. What can I do for that? Multiply this equation by 2. So this equation will become what? If you multiply it by 2, 2a, 4b and 3 2s are 6. Now you subtract these two equations. So if you subtract these two equations, what will you get? So minus, minus, minus. 2a minus 2a, cancel. Minus, minus, minus of minus will become plus. So 4b plus b, 5b. Minus, minus, plus. 6 plus 4, 10. So this implies that b is equal to 10 upon 5 is equal to 2. So we are getting b is equal to 2. Okay. Now if b is equal to 2, a will be what? A will be what? So we have the equation here. Now if b is equal to 2, how we will get value of a? So from this equation only, let us solve. 2a plus b is equal to 4. So 2a plus 2 is equal to 4. 2a is equal to 4 minus 2. 2a is equal to 2. So a is equal to 1. So we have got a is equal to 1. And similarly, we don't have space, but similarly you can solve for C and D as well. These type of questions are asked every year, so you should practice them. Okay. Now, this is your homework question. I am giving it for practice. Solve this question and comment the answer. I will check who all is answering this correctly. And those who answer it correctly will get a heart from us. Okay. Now, coming to the next topic, addition of matrices. So, how do you add two matrices? Again, if you want to add the matrices, the order should be same. Order should be same. Okay. So, if you want to add A matrix with B matrix, simply what you will do? First element added with first element. A11 plus B11. A12 plus B12. A13 plus B13, like this. So, same a 2 cross 3 matrix will be formed by just adding the respective elements. Okay, let me show you an example. If A matrix is this, B matrix is this, find A plus B. A plus B will be equal to root 3 plus 2, 1 plus root 5, minus 1 plus 1, 2 minus 2, 2 minus 2, 3 plus 3, 3 plus 3, 0 plus 1 by 2, 0 plus 1 by 2. So this is 2 plus root 3, 1 plus root 5, minus 1 plus 1, 0, 2 minus 2, 0, 3 plus 3, 6, 0 plus 1 by 2, 1 by 2. And this is your answer. This is A plus B matrix. Okay. Next, there are some laws of matrix addition. What are they? Yeah. First is commutative law. It says that if you add A with B or B with A, answer will be same. You should remember these. They can be directly asked in the question. Okay. Associative law, A plus B added with C, B plus C added with A, answer is same. Associative law is followed by addition. Existence of identity, any matrix added with zero matrix is the matrix itself. So if you add zero matrix to any matrix, you will get the same matrix. Okay. Negative of a matrix is basically if you change sign of all the elements. So what is negative of a matrix? Change sign of all elements. Then it is a negative of a matrix. Okay. Next is multiplication of a matrix by a scalar. How you do that? Suppose you have a matrix A, B, C, D, E, F and you want to find out what will be 3 times of A. So 3 times of A will be 3 times of A, 3 times of B, 3 times of C, 3 times of D, 3 times of E, 3 times of F. Just multiply all the elements with the number. Okay. Now, for example, if you have a matrix like this and they ask you what is 3 times of matrix A, what will you do? Just multiply all the elements with 3. Okay. 3 into 3, 1 into 3, 1.5 into 3, root 5 into 3, 7 into 3, minus 3 into 3, 2 into 3, 0 into 3, 5 into 3. So, it will be 3 3s are 9, 3 1s are 3, 1.5 into 3, 4.5, root 5 into 3, 3 root 5, 7 3s are 21, 3 3s are 9, 2 3s are 6, 0 3s are 0, 5 3s are 15. So, this is 3 times of A. So, this is how you multiply a number or a function with a matrix. Clear? Okay. Next is difference of a matrix. Difference is basically how you subtract two matrices. Again, same procedure. If you have two matrices and you want to subtract the elements, so basically you will just subtract first element with first element, second element with second element, third element with third element, like that. Simply, just like you did addition, same to same you will do subtraction also. Okay, subtraction is asked in question paper. Next, multiplication. Now this is important, a little tricky, so just observe carefully. For multiplication, there is a rule. In the exam, if they ask you, can you multiply a matrix with order 2 cross 3 with a matrix order 2 cross 3? Can you multiply them? No, you cannot multiply them. Why? Listen very carefully. Multiplication can happen only when the number of columns of the first matrix is same as number of rows in the second matrix. So number of column, number of row should be same, only then the multiplication can happen. Clear to all of you? So if the matrix is M cross N and if the B matrix is N cross P, so here the number of column, here the number of rows, if they are same, only then you can do the multiplication. Rule is clear? Now, how you do the multiplication? Observe. Now, this is a 2 cross 2 matrix. This is 2 cross 3 matrix. Number of column, number of rows, same. So, we can multiply them. Now, observe how you multiply them. A into B will be equal to, for here, how you multiply is, let me just first write down the formula for you. Okay. Row number 1 of A multiplied with column number 1 of B. Okay. Row 1 of A multiplied with column 1 of B. Again, row 1 of A multiplied with column 2 of B, and so on. So, let me show you with the example here. Okay. So, first what we will do, 6 and 9 multiplied with 2 and 7. So, here we have 6 into 2 plus 9 into 7. Like this you are doing the multiplication. Then 6 into 6 plus 9 into 9. Then 6 into 0 plus 9 into 8. Okay. After that, now we will multiply row 2 with each column. Column 1, column 2, column 3. Okay. So 2 into 2 plus 3 into 7. 2 into 2 plus 3 into, 2 into 6 plus 3 into 9. 2 into 0 plus 3 into 8. Now you find the solution. 6 2s are 12, 7 9s are 63, 6 6 are 36, 9 9s are 54, and 9 9s are 81. 6 zeros are 0, 9 8s are 72, 2 2s are 4, 7 3s are 21, 6 2s are 12, 9 3s are 27, 0 plus 24. Now, you can simplify this and get the answer. I am pretty sure that you can solve this further. So, simply just add all of them and you have the matrix. Okay. So, even if you don't know, let me only write it for you. So, 12 plus 63 will be what? 3 plus 2, 5, 6 plus 1, 7. This will be 7, 8, 9, 10, 11. this will be 72, this will be 25, this will be 39, and this will be 24. So like this you have your matrix. So AB matrix is 75, 117, 72, 25, 39, 24. This is your A into B matrix. Clear? Now let's see the properties of multiplication of matrices. First is associative law. A into B into C is equal to A into B into C. Distributive law. A into B plus C is equal to A into B plus A into C. Just like we have learned in integers, rational number, same for matrix also. A plus B into C is AC plus BC. Okay? Then existence of multiplicative identity. What should be the identity element? Any matrix multiplied with identity matrix is always same matrix. Now what is identity matrix? Remember 1 0 0 1 having 1 1 1 in the diagonal. Okay. Now one very important property, please note down carefully. Non-commutative law. Non-commutative law says that A into B is not equal to B into A. Okay? A into B is not equal to B into A. Never equal to B into A, not necessarily equal to B into A. Okay? So you should never write it like that. Alright. Next is zero matrix and the product of two non-zero matrices. So what happens here is, if they are telling that A into B matrix is 0, then A matrix is 0 or B matrix is 0 is not necessary. Not necessary means even if A matrix is not 0, B matrix is not 0, still A into B can be 0. So if they ask you, if A into B is a 0 matrix, A is 0 or B is 0, you should say there is no requirement for A to be 0 or B to be 0. It can be a non-zero matrix. Okay. Next. Second last topic of this chapter is transpose of a matrix. Now what do you mean by transpose? If you have an A matrix, A, B, C, D, E, F, where it is a 2 cross 3 matrix. So, A transpose of A matrix is basically the row becomes the column. So, it will become A, B, C. Row 2 will become column 2. This D, E, F. Now, this is transpose. So, row becomes column in the transpose of a matrix. Simple. So A, B, C, D, E, F will become A, B, C and D, E, F. So it will become a 3 cross 2 matrix. The order will be interchanged. Clear to all of you what is a transpose of a matrix? Now, suppose your question is, if this is a 3 cross 2 matrix, find A dash. Now, A dash and A transpose are same thing. Okay. So how you will find out A transpose? Just interchange the row and column. This is row, it will become column. Again, this is a row, it will become column. Again, this is a row, it will become column. And you have the transpose matrix 2 cross 3. For a 3 cross 2 matrix, you will get a 2 cross 3 matrix. Clear what is a transpose? Now let's see the properties of transpose of a matrix. Transpose of a transpose is the matrix itself. Remember, these properties are asked in the question. So remember, A transpose whole transpose is A back again. Similarly, a number multiplied with A whole transpose is basically a number multiplied with A transpose, because 3 transpose is 3 only. The number does not change. How can a number change? It does not have a row and column, right? Similarly, very, very important law. A plus B whole transpose is A transpose plus B transpose. But A into B transpose ठीक है, A into B transpose is not equal to A transpose B transpose. It is rather equal to B transpose into A transpose. Okay, so A into B whole transpose is equal to first B transpose then A transpose. Okay, this is an important identity you should remember. Next are two special types of matrices formed with the help of transpose. Now, if a matrix and its transpose are equal, then this matrix is called as symmetric matrix. So easy, right? Similarly, if a matrix and its transpose are negative of each other, so if A transpose is equal to minus A, then A is called as skew symmetric matrix. Skew symmetric matrix. If A transpose is equal to minus A, clear? Then it is called a skew symmetric matrix. Now, there are some okay. Sorry. I'll just write it over here. If A transpose is equal to minus A, then A is called a skew symmetric matrix. Okay. Now, two important theorems, please remember. For a square matrix to be having real entries, A plus A transpose will be symmetric and A minus A transpose will be skew symmetric only. See, if you add A and A transpose, you will get another matrix. Now, this matrix is also symmetric nature. Symmetric nature means symmetric in nature. Symmetric in nature means that B transpose will be equal to B. Okay. Similarly, if you add A and minus A transpose, you will get a skew symmetric matrix. Now, one very important formula. Every matrix can be represented as A plus A transpose, a symmetric matrix, plus A minus A transpose, skew symmetric matrix, whole divided by 2. Every matrix can be represented like this. There are two theorems. Okay. Now, last topic of this chapter, again a super important topic asked every year in the question paper. Inverse of a matrix. You will also learn this in determinants chapter, but for now in matrices also it is used a little bit. What is inverse of a matrix? If A into B matrix is equal to identity matrix, then B is called as A inverse. Just like we have learned in numbers also, na, that 3 into 1 by 3 is equal to 1. So 1 by 3 is inverse of 3, reciprocal of 3. We have learned it like that, na. Similarly here, if A into B is identity matrix, then B is basically inverse of A. Now remember this super important formula. It is used at a lot of questions. If there is a matrix A, B, C, D, then the inverse of the matrix will be 1 upon A into D minus B into C. Okay, this diagonal minus this diagonal, 1 upon. And what happens here is, please note it very, very carefully. This diagonal is interchanged. Interchanged means D will come in the place of A will come in the place of D. Clear? And the second diagonal, this diagonal sign changes. B will become minus B, C will become minus C. And like this, you will get inverse of A. Okay? Now, this part is called as determinant of A. This part is called as adjoint of A. And like this, you get inverse of A. I will show you a question, so don't worry. Based on this, I will make you practice question also. Okay, now two important theorems related to inverse of a matrix. You should remember that if A and B are invertible matrices, then A into B inverse is equal to B inverse into A inverse. It is very similar to A into B transpose is equal to B transpose into A transpose. Just like that for inverse also. For inverse and for transpose, we follow same rule. Okay? Yeah. Now a quick check, a quick question for all of you. Let's try to solve this. If the matrices A and B will be inverse of each other only if dash. When can you say that they are inverse of each other? If AB is equal to BA? No. If AB into BA is 0? No. If AB is 0, BA is I? No. If AB and BA is identity matrix? Yes. We have seen na A into B should be identity matrix. What is identity matrix? Always remember 1, 0, 0, 1. 1, 1 diagonal. Okay. Alright. So we have completed the revision of the chapter. Let's practice previous year question paper questions asked in the last 5 years. After that, I will also show you the formula cheat sheet and the mind map of this chapter. Alright, so let's solve the question. Question number 1 on your screen. If A matrix is this, A minus B matrix is this, then what should be B matrix? Interesting question. Let's find out. See, here I have A minus B is equal to minus 2, 1, 4, minus 9. This implies that if I bring this here and if I bring this here, so A minus this matrix minus 2, 1, 4, minus 9 will be equal to B. So if I want to find out B matrix, I should subtract this. So A matrix minus this matrix minus 2, 1, 4, minus 9. What is A matrix? 6, 2, 7, minus 5 minus 2, 1, 4, minus 9 is equal to B matrix, is equal to B matrix. So this is 6 minus minus 2, 2 minus 1, 7 minus 4, minus 5 minus 9 is equal to B matrix. So we get here 6 minus 6 plus 2, 8, 2 minus 1, 1, 7 minus 4, 3, minus of minus plus 9 minus 5, 4. So this is B matrix 8, 1, 3, 4. So which option? Yeah, 8, 1, 3, 4. Option D is the right answer. Okay, next question. If this matrix multiplied with this matrix is this matrix, find the value of alpha. First you have to do multiplication, then you have to do equality. So first let us multiply them. I will do direct multiplication because I have already taught you how to multiply. So what we do here is row 1 into column 1. Okay, so minus 1 into 1 plus 3 into 0. Then you have minus 1 into 2 plus 3 into 7. Similarly, 4 into 1, 4 into 1 plus minus 5 into 0. And 4 into 2 plus minus 5 into 7. 0 into 1 plus 2 into 0. 0 into 2 plus 2 into 7. This is equal to minus 1, 19, alpha, minus 27, 0, 14. Now let's multiply. We get, now, since it is not a subjective question, it is an objective type question. Do I need to solve the entire matrix? No, there is no need to solve the full matrix. Save your time. You just need alpha. So you just need this value, right? So this value is basically, alpha is basically 4 into 1 plus minus 5 into 0. So this is 4 plus 0 is equal to 4. So alpha should be 4. No need to solve the entire matrix, right? Next question. See, I told you na, equality of matrix is asked every year in the question paper. See, this type of question asked every year in the question paper. Let's solve it quickly. 3x minus y is equal to 7. X plus 3y is equal to 9. Again, same method for solving it, multiply it by 3. So you will get 3x minus y is equal to 7 and 3x plus 3 3 is a 9y and 9 3 is a 27. Subtract, subtract, subtract. This is 0. This is minus 9y minus y minus 10y and 27 plus 7 is 34. No, sorry, we will subtract. Minus 27 plus 27 is minus 20. So you have y is equal to 2. है ना? Minus 20 divided by minus 10 is 2. So y is 2. So you have y is equal to 2. Now find out the value of x. So 3x minus y is 7. 3x minus 2 is 7. 3x is equal to 2 plus 7 is equal to 9. So x is equal to 9 by 3 is equal to 3. So y is 2, x is 3. Now find out z. Z is this, right? So 2x minus z is equal to 5. X is 3. So 2 into 3 minus z is equal to 5. 3 2 is 6 minus z is 5 minus 6 minus 1. So this implies that z is equal to 1. So z is 1. So 3 plus 2 plus 1 is how much? 3 plus 2 plus 1 is 6. So x plus y plus z is 6. Okay? Because x is 3, y is 2, z is 1. So 3 plus 2 plus 1 is 6. Clear? Okay. Next, inverse of a matrix. I told you now these type of questions are asked every year. Inverse. If this is inverse of this matrix where AD minus BC is 1, then G is equal to dash. First, find if, let us suppose this is A matrix, what will be inverse of A? A inverse will be, remember I told you the formula, 1 upon AD minus BC into what matrix? Change them, interchange. A will become D, D will become A. And change the sign. B will become minus B, C will become minus C. So this is inverse of the matrix. In the question they are telling AD minus B is equal to 1. So this is equal to similarly, simply D minus B minus C A. Now in the question they are telling inverse is EFGH. So inverse is equal to EFGH. And they are asking you what is G? G is minus C. So your answer is G is minus C. Simple. That's why just remember that formula. Everything else is super easy. Okay. Next question. A matrix is this, B matrix is this. Find out 4A plus 5B minus C. Then C is equal to dash. Let's do it quickly. What is 4 into A? 4 into A is 4 5s are 20, 4 zeros are 0, 4 1s are 4, 4 zeros are 0. Okay. Similarly, what is 5 times of B? Now what I will do is, I will simply add them. Okay. This plus 5 times of B, 5 into B. 5 0 0, 5 1 is 5, 5 into minus 1, minus 5, 5 zeros are 0. Okay. Minus C is equal to 0. So let's just add them. You get 25, 4 and minus 5, minus 1, 0 and 0, 0 is equal to C. Because minus C will go to this side, it will become plus C. So this should be your answer. 25 minus 1, 0. Right answer. Okay. Next question. If U matrix is this, then U inverse is dash. What is the formula? Remember, this is A, this is B, this is C, this is D. So U inverse formula is 1 upon A into D minus B into C multiplied with matrix. Which matrix? D, A minus B minus C. है ना? Now what is D? 1 by root 2. What is minus B? minus of minus plus 1 by root 2. Minus c is minus 1 by root 2 and a is 1 by root 2. Okay. Now let us put AD and BC. What you will get? 1 upon AD minus BC. So A is 1 upon root 2 into D. D is 1 upon root 2 minus 1 upon BC. So minus 1 upon root 2 into 1 upon root 2. So minus of minus will become plus. So this becomes 1 upon 1 by 2 plus 1 by 2. Half plus half is 1, right? So this becomes 1. So AD minus BC becomes 1. So therefore, U inverse becomes what? U inverse AD minus BC is becoming 1. Hai na? Let me just write it over here. 1 upon AD minus BC is 1 upon 1 by 2 plus 1 by 2 is equal to 1. So therefore, U inverse is this 1 by root 2, 1 by root 2 minus 1 by root 2, 1 by root 2. Okay. Now, this is what? This is U inverse. But in the options, they have given you U transpose, U1, 0. Now, is this equal to 1? No. Is this equal to 0? No. Is this equal to U transpose? Matrix transpose. Let's find out what should be the matrix transpose. So, here, if U matrix is this, U transpose will be what? U transpose will be row becomes column, column becomes row. So, this row will become column 1 by root 2 minus 1 by root 2. 1 by root 2, 1 by root 2. Now see, this matrix and this matrix are same. So, this implies that U transpose and U inverse are same. So, this is your answer. Okay. Next question. This multiplied with this added with this is equal to dash. Let's do the multiplication. Row multiplied with column. So, we have 7 into 2 plus 1 into 3 plus 5 into 1. Yeah. Then we have 8 into 2 plus 0 into 3 plus 0 into 1 plus 5. 1 is a 5, 5 0 is a 0. So here we have 7 2 is a 14, 1 3 is a 3, 5 1 is a 5. Then we have 8 plus 0 is equal to, plus 5 and 0. Now 14 plus 5 is 19, 19 plus 3 is 22. So 22 and 8 plus 5 and 0 will be how much? 27 and 8. So this should be your answer. We are getting 16. Have we done anywhere? Oh, I'm so sorry. 8 2s are 16. Why have I written 8? My bad. 8 2s are 16, 8 2s are 16, 8 2s are 16. So 27 and 16 is your answer. Clear to everybody? Okay. Next question, again equality of matrices based question. Let's do quickly the multiplication. Row number 1 multiplied with column number 1. So it is 1 into x plus 2 into y plus minus 3 into z. Then 0 into x plus 4 into y plus 5 into z. And 0 into x, 0 into y and 1 into z. This is equal to 1 1 1. It is given in the question. Solve the equations. So you get first equation as x plus 2y minus 3z. Next is 4y plus 5z. And next is z. This is equal to 1 1 1. So clearly from here we can tell z is equal to 1. So z is equal to 1. Next, 4y 5z is 1. Another equation we have 4 into y plus 5 into z is 1. Now z is 1. So 4y plus 5 is equal to 1. 5 will go this side. 4y is equal to 1 minus 5 is equal to minus 4. So y is equal to minus 1. So we have y is equal to minus 1. And lastly we want x. So x will come from the equation number 1. Let's solve the equation number 1 also. 1 into x, 2 into y, 3 into z. Where should I solve it? Here. Let me solve it here. So x plus 2 into minus 1 minus 3 into 1 is equal to 1. So x minus 2 minus 3 is equal to 1. Yeah, correct. So we have x minus 5 is equal to 1. So x is equal to 6. So we should get x is equal to 6. So our answer is x is 6, y is minus 1, z is plus 1. Got the same answer, right? And the chapter is over now. So I hope that matrices will be super duper rocking in your exam, because from matrices, majority questions are asked from equality of matrix and inverse of matrix. Just practice these two topics and you'll get 100%. But of course, I have revised the entire chapter for you. Okay. Now, let's summarize the entire chapter with mind map and formula cheat sheet. So, here, if you have rows, what are the rows? They are the horizontal numbers. What are columns? They are the vertical numbers. Now, elements are basically all the numbers and functions written inside a matrix. Number of elements are always equal to number of rows into number of column. And order of a matrix is read as number of rows by number of column. Next, if there is only one column, it is called as column matrix. What we call it? Column matrix. If number of rows is equal to number of columns, square matrix. Number of rows not equal to number of columns, then non-square matrix, or you can call it as rectangle matrix. Number of rows is equal to 1, row matrix. All non-diagonal elements are 0, diagonal matrix. All diagonal matrix are same, k, 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 so it is a scalar matrix. All diagonal elements are 1, 1, 1, so it is identity matrix. All elements 0, so it is a 0 matrix. Okay. Next, how do you add two matrices? First element plus first element, second element plus second element, like that. Commutative law says that a plus b is equal to b plus a. Existence of additive identity says that a plus I is equal to a. Associative law says that a plus b plus c is equal to a plus b plus c, right? Now for multiplication we have, it got shifted here, it will be written here a4 b4. So it is row 1 multiplied with column 1, row 2 multiplied with column 2, like that. Remember, for multiplication AB is not equal to BA. A into I is equal to A. Associative law and distributive law is followed. Next, transpose of a matrix is basically row becomes column, column becomes row. Property of transpose, A transpose is A. K into A transpose is just K into A transpose. AB transpose is B transpose A transpose. And A plus B transpose is A transpose plus B transpose. Okay. And lastly, there are two types of matrices. If A transpose is equal to A, symmetric. If A transpose is equal to minus A, skew symmetric. And this law is followed by symmetric and skew symmetric matrices. Okay, and lastly you have inverse of a matrix. Now invertible matrix have the following properties, and remember the formula. If your matrix is A, B, C, D, then inverse of the matrix will be 1 upon AD minus BC into DA minus B minus C. Alright. So this is the complete chapter revision for matrices. Now you will be able to easily score 25 to 30 marks from this chapter itself. So if you enjoyed today's lecture, hit on the like button, subscribe to this channel and follow us every day for KEAM updates and revision videos. Thank you guys for watching today's session. Hope it was useful. In the comment section, mention your homework answer and do let me know that you are enjoying the lecture or not. See you in the next lecture. Bye bye.